Have you ever stopped to consider the profound impact that water diversion projects have had on the course of human history? Water, that life-giving, thirst-quenching, crop-nourishing element, has been the lifeblood of civilizations since time immemorial. Yet, it is not enough for water to simply exist. It must be in the right place, at the right time, in the right quantities. And so, our ancestors began the grand endeavor of water diversion, a task that would shape the course of human history. Think of the early civilizations. Their survival hinged on their ability to harness and control water. Whether for agriculture, drinking, or sanitation, the ability to divert water from its natural course meant the difference between flourishing and perishing. It was a testament to human ingenuity and survival instinct. From the verdant banks of the Nile to the fertile valleys of the Indus and the Yellow River, civilizations thrived because they could divert water to irrigate their fields. This not only provided food for their people, but also allowed for surplus, leading to trade and the birth of economies. Water diversion was not only about survival, but also about connectivity. Consider the great canals of history, like the Grand Canal in China. Built over 1,000 years ago, it was not just a marvel of engineering, but a veritable lifeline that connected the north and south, enabling transportation and fostering trade. The evolution of these projects over time is a testament to human progress. From the simple irrigation ditches of the ancient world to the grand canals and dams of today, these feats of engineering reflect our ever-increasing mastery over our environment. This journey of water diversion is not just about the past, but also about the future. It is about how we continue to shape our world and how we meet the challenges of a changing climate and growing population. Let us journey back in time to explore some of the earliest known water diversion projects. Our journey begins in the cradle of civilization, ancient Mesopotamia. Here, nestled between the Tigris and Euphrates rivers, the inhabitants of this land developed one of the first sophisticated irrigation systems. As early as 4000 BC, the Mesopotamians were digging canals to divert river water to their fields. This allowed them to grow crops on a scale previously unimaginable, leading to a surplus of food which in turn enabled the rise of cities and the development of complex societies. Next, we move east to ancient Persia, around the first millennium BC. Here, a remarkable system of underground tunnels known as canals was developed. These canals, which sometimes stretched for miles, were painstakingly dug by hand through hard rock to tap into underground water sources. The water was then channeled to the surface, providing a reliable and sustainable source of water for agriculture and everyday life in an otherwise arid landscape. The genius of the canal system was not only in its engineering, but also in its sustainability, ensuring the careful management of precious water resources. Our journey then takes us to the grandeur of the Roman Empire. The Romans built an extensive network of canals and aqueducts to meet the water needs of their burgeoning cities. These engineering marvels, some of which are still standing today, transported water from distant sources, sometimes over hundreds of miles, using only the force of gravity. The aqueducts not only supplied water for public baths and fountains, but also for private households, a luxury unheard of at the time. These early water diversion systems laid the groundwork for the ambitious projects that would follow. They were a testament to human ingenuity and resilience, showcasing our ability to adapt and thrive even in challenging environments. And as we'll see in the scenes to come, this spirit of innovation and problem-solving is a thread that runs through the history of water diversion, from the canals of Mesopotamia to the dams and reservoirs of the modern world. As we move into the Middle Ages and the Renaissance, we see a surge in innovative water diversion projects. The Middle Ages, a time often misconstrued as the Dark Ages, was in fact a period of profound innovation and development, particularly in the field of water engineering. Medieval Europe saw the rise of windmills and watermills, a testament to the ingenuity of the time. These mills, powered by the force of the wind or the flow of water, were used to grind grain, cut timber, and even forge iron. These were not merely functional structures, but symbols of progress, turning the raw power of nature into something useful for society. Meanwhile, during the Islamic Golden Age, scientists and engineers were making strides in their own right. They constructed aqueducts, complex systems of bridges and canals, to transport water from rivers and wells to cities and farms. This was a time when water wasn't merely seen as a life-sustaining resource, but as a tool that could be harnessed and utilized for the betterment of society. These aqueducts weren't just feats of engineering, They were a testament to the scientific spirit of the age, a spirit characterized by curiosity and the pursuit of knowledge. But perhaps one of the most iconic examples of water diversion in this period is the city of Venice, a city built on water. Its canals, the veins of the city, were not naturally occurring but were the result of careful planning and construction. These waterways served as the lifeblood of the city, enabling trade, transportation, and communication. Venice is a testament to human resilience and adaptability, a city that turned its watery challenges into its greatest strength. These projects showcased human ingenuity and the increasing understanding of engineering and hydraulics. They marked a significant leap forward in our relationship with water, a leap that began with simple wells and rivers, and would eventually lead us to the massive dams and reservoirs of today. The Industrial Revolution brought about a new era of water diversion projects, driven by the need for power. As the wheels of industry began to turn, the demand for energy sources increased dramatically. Water, an abundant and renewable resource, quickly became a vital player in this burgeoning industrial landscape. The construction of dams and reservoirs emerged as a pivotal method for harnessing the power of water. These impressive structures, built across the breadth of rivers, were designed to control the flow of water, creating a significant elevation difference that could be exploited for energy generation. By releasing controlled amounts of water from the reservoir, the stored gravitational potential energy was converted into kinetic energy, turning the turbines of power stations and generating electricity. This was a game changer. The power of water was no longer just about providing for human survival, but about fueling human progress. It was a time of great industrial growth and innovation, with the construction of dams and reservoirs playing a central role. But the power of water wasn't only harnessed for electricity generation. It also played a significant role in transportation. With the creation of canals, water was diverted to create navigable waterways. These man-made channels served as the highways of the time, allowing for the efficient transportation of goods and people. Canals were a testament to human ingenuity, transforming the natural landscape and connecting communities in ways previously unimaginable. The use of water for power generation and transportation was a testament to the adaptability and resourcefulness of humanity. These water diversion projects were not without their challenges and controversies, but they represented a crucial step in our collective journey towards harnessing the power of nature for our benefit. From powering the machinery of factories to lighting up homes and facilitating trade and travel, the power of water proved integral to the growth and development of societies around the world during the Industrial Revolution. These projects transformed landscapes and powered the engines of industry. In the 20th century, water diversion projects reached new heights of ambition and scale. The construction of the Hoover Dam, the Grand Coulee Dam, and the Three Gorges Dam in China are testaments to this. The Hoover Dam, completed in the early 1930s, stands as a marvel of human ingenuity and resilience. Nestled in the Black Canyon on the Colorado River, it was built during the Great Depression and still serves as a critical provider of water and hydroelectric power for the Southwest. Moving north, the Grand Coulee Dam on the Columbia River in Washington state was completed in the 1940s. Considered one of the largest concrete structures in the world, it provides irrigation, flood control, and electricity to the Pacific Northwest. Its creation, however, came at a significant environmental cost, disrupting salmon migration and altering ecosystems. Crossing the Pacific, we find the Three Gorges Dam in China, the largest hydroelectric dam in the world. Completed in 2006, it generates an astonishing amount of power, but at an equally astonishing cost. The dam has displaced over 1 million people and has caused significant environmental changes. These projects have had a profound impact on our world, for better and for worse. They have powered cities, fueled economies, and reshaped landscapes. Yet, they also remind us of the consequences, both environmental and social, that come with such grand undertakings. As we reflect on the history of water diversion, we are reminded of its crucial role in human development. From the ancient civilizations that first channeled rivers to modern marvels like the Grand Coulee Dam, these projects have shaped our world. They've enabled cities to thrive in arid regions, powered our industries, and even redefined geographical landscapes. So the next time you turn on the tap or cross a bridge, take a moment to consider the long and complex history of water diversion that made it possible.